Swayam Prabha. Digital India. Educated India.
The next important topic in CNC is going to be manual part program, an example. So, we will try to start from here. This is a component. So, we will try to start from point P0, then we go to P1. Okay. This is all in inches, by the way, these are all in inches. So, we will go to P1. From P1 we will go to P2. Okay. You know the length, you know the angle which is set 45 degrees. Then from here you will try to come here offset, then you have a radius. So, the radius is divided into 2. So, this is one clockwise, if you take it as counterclockwise, and then this becomes your clockwise, whatever it is. So, you can try to do up to here and then you can try to split up to here, or you can use the same command and then swing it up to here. P4. So, this will be G00, this will be G01, this will be G01, this will be either G02 or 3 depending upon your requirement, and then this is G01 and then G01. So, if you wanted to do the component while machining, so here are the tool sizes given, feed rates, cutting speed, starting point, everything is given. So, this is P2, 2, this is what is given here. The program is in inches. So, we write P0, P1, P2, P3, P4, P5, P6, P5 and P1 and then P0. So, if you want to make a component, so this is how a sequence has to be followed. Again here you can choose either to do absolute or you can do incremental one. So, let us do step by step by step. First, set up the part programming. So, first block you write N010. So, the entire program is inches G70. We are going to follow absolute G90. So, here it says the feed is in inches and then we have this is inches, then we have spindle speed in RPM and then we will try to have spindle on which is in the counterclockwise direction. So, then N02 I am trying to move, G17 is the plane XY plane I am going to use, and then use full circle interpolation is G75, then we are defining the feed, cutting speed, tool number and finally the flood coolant on. Miscellaneous will come at the last. This is second point. Then the third one is we are at N03, we are saying G01 X 3.857 and Y is 3.698. So, this is the target coordinates to the end point what it has to go. So, now from here it will try to go here. So, this is P1, this is P1. So, here if you look at it, so this is P1. So, here it is 4, 4, this point is 4, 4. So, now I have to go stop here. So, I have to find out the point. So, it is 4 minus 1.25 times which is the diameter. So, it is 3.85 comes here and y axis is this. So, it is divided by tan 22.5 which is nothing but 44 divided by 2. So, it is 3.68. So, this will be my end point. So, from P0 I have to go towards the destination point of P1. So, this will be there. So, all the feeds and speeds we will take, this is the feed and this is the speed and the tool 1 is used for the operation. Next, from here I will try to do a linear interpolation which will go from here N0, N40, G01. So, now from here I have to go up to here. So, what I will do is I will try to, because this is 4 and this is 5. So, this is 9 inches. So, I will have to go X 3.875, I will go up to P2 destination which is 9.125. Why is this 125? Because we have told the diameter of the cutter is 0.25 inches. So, half of it. Okay. I can write it like this, since there is no change in the x coordinate point. I can directly write G04, G01 and then I can say y 9.1. So, the x value is assumed to be the same. The x coordinate does not change, so no need to change in the program. We are following absolute scale. Then from here I have to come up to here. So, this is what is N050, G01 I have to say from here it is 9.25 which is fixed, and from here I know it the diameter up to here or the length up to here is 2.5 and I have to this radius is 1 inch. So, now I have to subtract it and find out what is P3. So, P3 is a point here. So, we know the diameter is 2.25. So, radius is 0.125. So, it is this is your x axis and this is your y axis and this is your x axis. So, x value will be 9. So, this will be the x value, it is 6.5 minus x the whole square plus 125 the whole square. This is going to be your x value. So, x is this and 9 it is the same. So, it is 9.25 is there. So, this point is going to be 6.5 comma 9. This point is so, and then from here we are going to draw a radius which is around about 1 inch. We will try to take this center and draw. So, currently we are up to here, then from here we have to move here so that you can swing the radius to get it. So, here what they say is they say that this total is 5 inches and then this is 2.5. So, this point plus 2.5 will try to give me the center. I have to find this point. Next one is circular interpolation, counterclockwise motion. So, N60 G03. So, it is from here I have to swing it around up to here. So, it tries to tell me the point, so which is 7.366 and y is along a straight line 9.25 and I and j are the coordinates of the center of the circle, or you can try to define the radius of r. You can write it like this and then, or you can write it like N60 G03, x is the same, y is the same, I 0, you can define r 0.8, then you can go up to this point. Then from here we have to go along a straight line. So, it is N70 G01. Now, I am not changing the y value, it is only the x. I go to x 9.302. So, the target value of y is unchanged. So, it is linear interpolation. Here it was circular, counterclockwise circular. So, here it is linear. So, now from here I will have to go again a linear towards the point P1. So, G80, so N080, G01. So, from here I am trying to go to this point which was 3.875, y is 3.698, I come to this point P1. And then from here I will try to move here. So, it is G01, so x2 and y2. So, I come to this point and I say end of the data and then I say N100 M00 stop the program. So, the complete part is executed in this program. So, we have done it in 9 steps. So, if you see this complete CNC program, we have done step by step by step by step. So, you will know P0, P1 how to go, P1, P2, P3, P4. Now, interestingly, the latest softwares have come up in a great way. So, you do not have to do so much of small calculations, what is the offset. You just have to define these points and the rest of the calculations will be done by interpolation techniques and the system takes care of it. So, you have to say P2, P3, P4, P5 and P1. So, then rest of the calculations it will take care and then you can easily execute the program. When I consolidately put this complete program into a number of blocks. So, this is how it looks like. First step N010, G70, G90, G94, G97, M04 we did it. Then which plane we are operating and then we are trying to talk about linear interpolation, then circular interpolation counterclockwise, then linear and finally, we say okay, we go there and then if you want to go one more step outside we can say G00, X0, Y0. So, it takes completely outside the component. So, here this you can write it in R plane, R radius or you can write it as I and J options. So, please keep that in mind, and just for simplicity you can start using R rather than using I and J. In the examination, if at all there is a program asked, so it is better you use R instead of I and J. So, now let us take, this is for a milling component. Now, let us see one example for a turning component. So, a simple G code example for a CNC lathe. As I told you, in milling you will have X, Y and Z 3 points, but in that program we did not have any Z value because we assumed the workpiece to a plate. So, it is a constant Z. So, that is why we did not define the Z value at all, but now here we can see how do we use the codes. So, in turning we will have only two axes. One, this axis is called as the Z axis and this axis is called as the X axis. If you look at the complete component, the component has to be faced and then it has to be turned, then you will have a taper in the turning and then finally you make it. So, the larger diameter is going to be dia 80 and the smaller diameter is going to be dia 50. The length of the shaft, whatever you have made, the length is going to be 30 and this length is going to be 50. Okay. So, exactly dot you can't keep the tool and start machining it, because if there is any undulation on the workpiece, the tool will get hit and the tool will get broken, the insert will get broken. So, what we do, we always try to move it to a place which is little far off and safely keep at that point. So, here what we do is we try to keep it at a safer point, and from the safer point we try to move it to the tip of the shaft. So, from here we go from A to B it goes, from B it goes to C and from C it goes to D and D it tries to finish the component. So, we are going to write our CNC program accordingly. We are not going to do facing operation. This is only a example. So, we are supposed to know how to write the coordinates along the given points A, B, C and D. So, it is very easy. So, from here to here there is no variation in diameter. So, it will be the same, only variation is going to be the Z. So, here you will have X as well as Z variation. So, let us see in words how are we going to write the code and then we will see the code. So, N5 is clamping of the workpiece, then N10 the changing number 1 tool and executing its offset, because the tool whatever comes you have to see what is the, you have to call the tool and then you have to say all these offset. Every tool will have a register, in that register you will try to record all the details relevant to it. Then you will start moving it to position A, from somewhere you will start moving to position A in a very rapid speed. Then you start the spindle with 600 RPM. So, before machining you will first start rotating the job and then only you will start doing. When you start rotating the job you will on for the coolant. Then once these two, A position is reached, job started rotating, coolant start on, then what will happen, the approaching point from A you will move to approaching point B with 600 millimeter per minute, because this happens in air, you are not touching the workpiece. So, this happens in air. So, you move in rapid speed. Then cutting from B to C happens at a given speed and feed rates. Then cutting from C we go to D point. Then after finishing the D point we retract the tool to come back to point A. Now, you should cancel the offset whatever you have given T01, then you will stop the spindle, switch off the coolant, release the workpiece and then you say end of the program. So, now we have described the complete sequence of operation for this particular program. So, I would give you as an assignment, please start working on this assignment and you can submit it to us for correction. So, let me see one more component, and this is a milling component. So, in this milling component we have given you a home position here, this is the home position, we are trying to follow absolute. So, it is at this point where x is minus and y is 86.95. From here we will use G00 come to here, which is this point. So, maybe we might take it this as 0 comma 0. So, this is a point which is 20 in x axis, y axis it is 0. So, you can try to take this as 20 comma 0. From here you are going to this point where we have given you the points 30. So, this is 0 comma 30, and from here you are going to this point where in which it is 10 offsetted from here, and from here it is 100. So, it is x axis it is 10, x axis it is 30, and y axis it is 100. This is the point. From here we are going to D. So, D is going to be, this is 150, and here from 150 we are going to go up to here. So, this point E is 150, 150 minus 10, it is going to be in x axis 140, and this is going to be 60. So, comma 60. So, from here we will go here. So, from here to here you have to use a circular interpolation. From here to here you will use a linear interpolation, and from here to here E will be, y axis will be 0. So, it is 150 plus 70. So, it is 170 comma 0, and here naturally. So, I have missed out this 20 which is there from the origin. So, it is going to be 160 comma 60. So, let us see the sequence of operations. For this part you will write the program and you will submit. So, when we try to look at the sequence, N5 absolute position, so G90 and metric units has to be used. Then you will have, next is call for tool 1, then define work 0 at a point A. So, if you want to define the point at A, you can make this as 0 0, or you can try to make this point as 0 0. I have made offset from this point as 0 0 and I have given this values, but if you want to follow the sequence what is given here, you can also do that. So, define a work 0 point at A, then rapid traverse from a different coordinate system to A with a spindle speed on, this is what it is. Then at Z you have to plunge 12.5. So, Z will be throughout the program minus 12.5, because this is 0 of your workpiece and this is 12.5. If you want to play safe, you can go even 16. So, a rapid plunge to 12.5 millimeter above 0. So, now the feed rate to Z minus 12.5 feed rate up to 150 millimeters per minute. Now, cut line AB to B, then from BC to C, CD to D, DE to E and EA to A. So, you are just going AB, BC, CD and then we are going back to EA back. So, now once you have finished all the cut, now after reaching here you have to retract that minus 12.5, 12.5. So, it comes above minus 12.5, 0, 12.5 it goes. So, then the reference point returns to Z direction, spindle is switched off, reference point returns to X and Y directions and end of the program happens. So, these are the sequence of operations. You just have to look into this program and then start writing. I have assumed this as my 0 0 and I have given the points, but here you please check whether they are talking the same. If it is same, use it. If there is a change from here understanding, please make the changes accordingly and write a program. Then let us look at one more program, sample program for drilling. So, you have, let us assume this is your 0 comma 0 and these are the points which we have given, and if you look at the slide view, it is not through hole drilling. The through hole of your plate will be 0.5, but you are trying to drill only 0.375. So, since it is a drill, you will always have this conical taper. So, you should have a flat, but since you are drilling and it is blind, you will have this depth, conical depth. So, the depth which is given here is 0.375. So, here it is all in inches. So, please try to execute this program, the previous 2 and then this program, 3 programs, and then you can share it across, or if you have doubts you can keep it for yourself. Now that we have understood manual programming, let us move to the next step called as computer assisted part programming. So, in computer assisted part programming, here it is APT or automatically programmed tools is a high level computer programming language most commonly used to generate instructions for numerical control machine tools. APT uses language statements to define part, shape and tool motions as well as machine tool dependent data, example feed rates, spindle speed. APT uses language statements to define part shape and tool motions as well as machine tool dependent data. The general procedure for generating APT source code involves the following steps: identifying the part geometry, identifying the cutter motion, feed, speed and the cutter parameters. Then we talk about the code, the geometric, cutter motions and general machine instructions into a part programming language. The code is known as a source code. We will see that. Then it is moved to a compiler or a process the source to produce the machine independent list of cutter movements and auxiliary machine control information known as cutter location data file, CL data file, cutter location. So, it compiles all the program and then it tries to take the cutter movement and the auxiliary machine control informations. An APT processor program is used to read these statements, interpret the meaning and perform all necessary calculations to generate a series of cutter location motions that are defined the tool path. The generalized APT output usually is a CL, cutter location data, is converted to the particular format G code required by the CNC machine using a post processor program. Then CL data file contains details of the cutter movement either as a series of absolute linear go to moves or relative go delta moves. Note that the CL data is different from APT. So, CL data is defined by the International Organization of Standards ISO. Then finally, you do post processing and transmit it to the MCD. So, this is what is a part programmer's job: define part, define tool path operation, specify other functions, speed, feed, etc. The computer's job will be input translation, arithmetic and cutter offset compensation, editing phase, and then it does a post processing. The sequence of activities in computer assisted part programming is very important, you should understand. Automatically programmed tools, a major advantage of APT is that it has developed into an acceptable standards for machine tools in addition to the burden, in addition to the elevating the burden of coding of very basic levels. The primary disadvantage of APT is that it uses English language command to define geometry instead of convenient graphical method. Note that APT type programming approach is being gradually replaced by more advanced CAD/CAM approaches. So, in APT, suppose let us assume this is a part which has to be done, and these are the points P1, P2, P3, P4, P5, P6, P7, P8 and P9. P1, P2 is joined together by a line L1, P2, P3 L2, P3, P4 L3, P4, P5 L4, P5, P6 L5, P6, P7 L6, P7, P8 L7, P8, P1 L8. So, now there are points P1 to P8 and there are lines which are L1 to L8. Okay. So, desired tool path and the geometric entities identified and labeled. This is a part and it is labeled. So, now the APT source code is part number example, machine is going to be mill 5, cutter is going to be of diameter D0. So, now what you do is you define all the points, then you define all the lines, then you will define a plane. What is a plane? And then you will say spindle on, feed rate, coolant. Then now what you say is move from P0, go to L1 to plane 1 on L8, go to P0, P1. So, it says go to L1, which is a line, to plane 1 on L8. So, you have to, this is meeting L8. So, you have to go to this point. From L8 there is a point coming, L1 there is a point coming, and then we say go to point number P1. Then you go left of L1 past L2, go to L1 past. So, you are crossing L1, go to L1, go left of L1, and then you say past L2 up to L2. So, L2 you have to cross, so that you go to this point L2, this is what is L2, and then you go to right of L2 to L3, then go left of L3 past L4, go right of L4 past L5, go right of L5 to L6, go left of L6 past L7, go right of L7 past L8, go right of L8 past L1. So, all these things will now, if you see closely watching, it will talk about how will the tool move to get to that profile. It is go left, go right, L1, L2. You have defined all these N1. So, here you do not use any G codes, M codes, nothing. So, you try to use this English language, and then you get, then go rapid, it is going out, then go to point 0, coolant is off, end of program, and then finish. So, this is just written in English. This is what we said here. So, a prime disadvantage of APT is that it uses English like command. So, here this also you should see, I told you. So, an APT post processor program is used to read these statements, interpret the meaning, and perform all the necessary calculations to generate a series of cutter location points. So, that is what is CL data file which will be generated. So, this is the APT source code which is generated. This will be compiled and you can use it. So, the next approach is going to be CAD/CAM approach. So, there will be a demonstration which will be done by Dr. Amandeep Singh on this topic, but let us quickly go through what is covered here. The CAD/CAM approach is the most popular and the advanced approach in generating CNC codes. So, here manually we do not do it, we will read the drawing, the system itself will read the drawing. From the read drawing, it will try to understand and it will try to give you the G codes and M codes. The process starts with creating a reference model and workpiece and then assembling them in a assembly mode. After the solid model are assembled, user defines the manufacturing setup, including choosing the work cell and the coordinate system. Then user creates a machining sequence depending upon the profile, and in the meantime user chooses a cutter and specify machining parameters. Then at this point a machine sequence is completely defined. CAD/CAM will generate a tool path, and the tool path was created using Pro-E, which is a commercially available software for this example. To summarize, what all we saw in this lecture is how the programming works in a NC machine, what are all the various axis motion, what are all the different types of part programming, then various preparatory and G codes, how to use manual and part programming, what is computer assisted programming, how do part programming uses APT, which is English based code, and a CAD/CAM programming where we will see a simulation. Thank you.